recording. There we go. Alrighty. Okay. So just a few things, fun stuff. I'm starting a new GitHub project called Free Acorns. So it's basically a project for me to encourage my colleagues to use open educational resources, which translates to you guys as, oh, I don't have to pay anything for my textbook. Um, so I chose the name Free Acorns instead of anything that has ARC in it, because if I use the term ARC, which is it's not exactly a trademark, but if I use that term or any logo of this campus, I'll get into trouble. So I just go like, well, since the oak tree is kind of um, the logo of ARC, I just go like, I'm going to use acorns. They cannot get me if I just say acorns, right? They cannot just say anything related to oak tree I cannot use. Then I'm going to use squirrels and stuff like that. It's like, okay, we can play this game. I can dance. Anyhow, so this may be where I will move some of my notes over, or the new ones may reside over here. I haven't quite decided yet. So there is that. Um, okay, so let me ask, does anyone want me to go over how to write the code that was due this morning? Or okay, so we got a few requests, okay, a few nods. Okay, that's good. So let's go ahead and do that. I intentionally pulled up the spreadsheet, okay, because the spreadsheet was intended to help you guys figure out the logic of the program. So we'll start with the spreadsheet because the spreadsheet has been done like a long time ago. In fact, I can check when it was done. So I can do a Shift Control Alt H to look at the history of the of the spreadsheet. So the spreadsheet has been around since the 3rd of October, and it was last revised on the 5th of October. So that's one cool thing you can do with Google Document and Google Sheet is you can actually go check out okay, what changes did I make, when did it start to exist, and so on and so forth. All right, so when you look at the spreadsheet and you say, I need to convert this into a program, okay? So the idea is, how do I structure the code to do this, okay? So I already mentioned in the class when I worked on the spreadsheet that this is going to be a double loop. In other words, we have a loop inside a loop that it's nested, okay? So the first thing you need to do is to identify, what is the outer loop and what is the inner loop. So the outer loop is the one where it goes slower, right? It's kind of like the hour hand of a clock, and then the inner loop is more like the minute or the second hand, which spins a lot faster. So what you need to do now is to say, okay, what is changed a lot and frequently, and what doesn't change very frequently, but nonetheless a little bit, over time. So what changes a lot and quickly would be the exponent of 2. Okay, that is decremented in a lot, and what goes with it is the doubling of the coefficient. So we can identify maybe that has something to do with the inner loop. The outer loop, on the other hand, seems to have something to do with the exponent of 10. So it changes, but it changes very slowly. Okay, so are we okay so far with the observation based on just the visual effect of the spreadsheet? Okay. So the next thing we now need to do is to say, okay, I want to deal with the inner loop first. Okay. Um, this type of programming is kind of bottom up. I try to handle the lower level logic first before I handle the higher level logic because you can debug it first. Then you have something that's reliable, so you can build something on top of that. Okay. So I look at this, inner loop and go like, okay, what do I need to do in the inner loop? Well, we do not seem to be doing anything with the exponent of 10, but we appear to be doubling the coefficient, and we also appear to be decrementing the exponent of 2 for each iteration of the loop. So what I would do is I'm just going to write very simple code to try to just to do that effect. So I'm not even going to start with this. Okay. So what I'm going to do is not going to be the correct code, but nonetheless it gives me a starting point. So I'm just going to say while true, do something here. And what I'm doing here is I look at the coefficient and I'm going to multiply that by 2. Do not tell me what's wrong with this code because I want you guys to think about it. And I also want to decrement the exponent. Okay, so once again, I know there's something wrong with the first line of code, but I don't want to say anything yet. Okay, so let's just say that this is what I did. Okay, and I just want to verify this code is going to do what it's supposed to do, which is doubling the coefficient with each iteration and also decrementing the exponent of 2 every single iteration. Yes, I know this is an infinite loop, but because I'm using the debugger, hey, it doesn't bother me, okay? Because I can just set up a breakpoint and I can examine the values of each member of the structure when I'm at a breakpoint. So I just want to see that this thing is happening the way it's supposed to. This is not intended as the final version of the program, simply as a starting point. Okay, so what do I do? Well, if I just run this code without using a debugger, that would completely be pointless because the program just goes into an infinite loop and it's not going to come back, right? So I need to set up breakpoints. So here's a breakpoint on this line. I can move it down maybe, okay? Because I want to stop at the very end after the E2 is decremented, right? And I also want another breakpoint at the very beginning so I get to see what is the structure pointed to by Pn at the entry point. I just want to verify everything looks good, right? So now what I do is I need to set up, this is something that I learned, it's new to me. I did not know that you can go to the input tab and actually specify the command over here, which is a nifty feature because this way, every time I run, it's going to run with these command line options. So that's nice, okay? Because what I used to do is to say, okay, R and then -n and then 1.23 E negative 45 every single time. This makes it so much easier, okay? Which is nice. So now what we do is we go into a debug session, okay? So we hit debug, and the program has not started. So the first thing is you have to start the execution of the program. And there we go. The program has started, and when you see the green rectangle, it means we are now at a breakpoint. Okay, execution has paused, not stopped. It has paused at this point. So that gives me a chance to take a look at what Pn has. I already have this watch expression, program in, and that's why it is showing the what Pn is pointing to. I can see the sign is 1. I can see the coefficient is 123, the exponent of 10 is negative 45, and the exponent of 2 is negative 12. All right, so the way we do this, in a display expression is you have to say, watch, I think that's how you set it up. Oh, not this. You can do it through the GUI. So you can enter an expression to watch. That's the way you do it. So if you don't know how to do it, let me just undo this first. And all you have to do at this point is to say, I want to watch whatever PN is pointing to. So this will show you the entire structure and not just one of the members of the structure. So it's kind of handy. I know the sign is not going to change too much. It's not going to change at all. But it doesn't. It's not too big of a deal. Is that okay? So now you press the enter key, and it doesn't show right now because it will show only when you hit a breakpoint, and we're already at a breakpoint at this point. All right. So, this is main. Okay, so we'll go ahead and continue execution. And we get here, this is in, okay, that cannot be displayed because we're at a different scope. So I have to use star pn again because it's not at the same scope as the previous one. All right. So if I cannot see it, I can always use the command line portion, which is at the bottom, and just say print whatever PN is pointing to. And it still complains about that memory address cannot access that location. That is weird. Okay, let me single step. So single step into, and forgot to put a breakpoint here. And now it shows, I guess at the entry point, something is different. But now I can see how um, when you get to a breakpoint, it's before that line has a chance to execute. So this is before the decrement happens, and before the decrement happens, it is a negative 47, which we know is right. Why? Because when you go back to the spreadsheet here, you can see how the exponent of 10 is supposed to be negative 47, and then the exponent of 2 is supposed to be 0. So when we go back to GDB online or online GDB, that is exactly what we're seeing here. So if I single step, okay, there are two ways to single step, which doesn't make any difference in this specific case. Stepping over means, if you're calling a subroutine, it won't stop in the subroutine itself. It just, calls the subroutine and then it stops again after the subroutine returns. Stepping into means, it will stop again, it will pause again in the subroutine that you're calling. Now, since we're not calling any subroutines, in this particular code, so that means it doesn't make any difference in this case. All right, but one thing we notice that is already wrong is the coefficient is supposed to double. It was 123, and it is still 123. Okay, so that seems kind of odd, but I'm going to step over and just run it again. Coefficient times 2, and it is not changed. But you can see how E2 is decremented. So we can see that in this case, something is changing and something is not changing. The coefficient is supposed to keep doubling, and it's not doubling. But E2 keeps decrementing. So I know I'm in the loop. The loop is doing what it's supposed to be doing. This is an infinite loop. So the question now is, why is the coefficient not doubling? I mean, isn't times 2 doubling something? The answer is yes, but it doesn't store the product back to anywhere in this case. Is that okay? Because I have seen this mistake a few times, and I might have personally made this mistake a few times. The thing about coding is not to make mistakes. It is okay to have bugs, write code that is not entirely correct. The question is there are two questions after that. One is, can you contain the bug? Two is, can you find the bug? So it is all about, in this case, about finding the bug. Okay, so the debugger is clearly showing us that the loop is happening. Okay, we don't have any problem with E2 being decremented. It's only that the coefficient is not getting doubled. So at some point, hopefully, we look at line 128 and notice that, yeah, this is syntactically correct, but it's just giving us a value that is not stored anywhere. So as a result, my program is not doing the doubling correctly. So what we need to do, there are a few ways to fix this problem. For those of us who do not, like myself, who do not like to type unnecessarily, ding, that will fix it.
Will that work in the just the plain C language?
Yeah, I'm using plain C all this time. Look at the language that I have chosen. This is just plain C. So the operator of multiply equal to, that is called a compound assignment operator, um, which I really hope that CISP 360 would have introduced, because um, that's a nice little feature to have. I mean, it is the same thing as coefficient equals to coefficient times 2. Okay, it's just that in terms of typing, it's so much easier. But it also makes it easier to make that mistake of forgetting the equal to and just have the multiplication. I think we have done that a few times myself. Okay, so now that we have quote unquote fixed the bug, let's try to take a look at the program again and see if it is doing it correctly this time. So we go back into debug, okay, keep everything else the same. It actually remembers, all of the watch expressions. So that is really nice, right? So we can go to start, and then we get to the main, okay, so we continue to the next breakpoint, which is at the entry point of the subroutine, and we can now see, the initial state of the coefficient E10 and also E2. So those are all cool. And then we say continue, and then we hit this breakpoint here. And this time, coefficient is still not multiplied by 2. That is strange, unless this is not getting updated. Let me see. No, it's getting updated here, so the display expression is just not getting updated. So this is a bug, or maybe it's displaying, what PN used to be in main. All right, so we'll continue. All right, so now it's working. You can see how, for each iteration, the coefficient is doubling and then E2 is decrementing. So at this point, I can now change the loop so it's not like a stupid, infinite loop, okay? Because, now I need to start to think about when am I supposed to get out of the loop, right? So we go back to the spreadsheet. So this entire session, what I'm talking about here, is not really just how to debug the program, and it also includes how should I put it? It's not exactly how to write a program, but how to approach writing a program. Okay, what clue do you use to help you think, oh, we need this, and then we need that, and also you can see that I don't write a program linearly. I don't start from the first line and then try to finish the whole thing, and then I start debugging. I mean, that seems like the best way to do it because it seems to be saving time because you're writing the entire thing. But to debug a program that is long, this one is short, okay? But to debug a longer program, like if you have written 100 lines of code and you try to debug the thing, that means you have 100 places where things can go wrong, right? On the other hand, if I do it like this, well, there are only a few lines where things can go wrong because I'm debugging the code as I go, okay? All right. So now, when am I supposed to stop? Well, you might remember that we have this column E here that stays true when we need to stay in the loop. And the moment it becomes false, we get out of the loop, right? So we need to take a look at this and take a look at over here, okay, when it becomes false. And it says, okay, so um, when the coefficient becomes this value, then the condition is false, and that's why we have to move on to the next column. So when you look at the equation or the formula, it is saying if twice of the coefficient is no longer less than 2 to the power 31, 32 minus 1, then we need to do something, okay? So that basically is telling you that there's no more room for another multiplication by 2. But in the class, I also mentioned that we only use 2 to the 32 to the power of 32 because in the spreadsheet, it cannot deal with um, integers up to 2 to the power of 64. And in your program, you're supposed to use the largest value that an unsigned 64-bit integer can contain. So now, going back to the program, I want to be able to exit correctly, which means I need to stop the debug session and then go to here and look at this condition here and ask, how am I supposed to express that here? Well, what I want to express is Pn points to coefficient is still less than times 2 is still less than or equal to the largest value that a 64-bit integer can contain. How you want to specify that? Well, I'm just going to shortcut here. It's uin64 max. Okay, this is a macro that is defined in the header file called standard integer.h. So if you did a little bit of research, you would find that. But on the other hand, if this is not how you used it, and you say, okay, 0x and then 14, 16 f's, that will work as well. Okay, so there are quite a few ways to specify the largest value. But if you recall, in class, I also said this is not going to work. This is just as good as an infinite loop because every 64-bit unsigned integer is going to be less than or equal to the maximum of a 64-bit unsigned integer. Okay, I'm just going to pause here to make sure that that sinks in and it makes sense to you. Because if you have a 64-bit unsigned integer that is not less than or equal to u in 64 underscore max, that means u in 64 underscore max is not the maximum. It becomes contradictory to what it's supposed to be. So this is why this comparison is not going to work. It is an infinite loop at this point. So how do we know this is going to be an infinite loop? Debug it. Very good. Now we're going to get into some more advanced, debugging technique now. Okay, so I will show you, what it looks like when you're not using that technique, but it's going to be tedious. It's not impossible. It's just tedious. So you hit debug, And we do the usual thing, start the program, continue execution, get to the subroutine, and we know that we kind of have to get rid of this because it doesn't seem to update between the debug sessions, so you kind of have to redo it every single time. So we're going to redo it now. Look at what is in PN, and then continue to this breakpoint, and you can see, okay, continue, okay, fine, keep going, da 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 da. Okay, so you're gonna say, how far do we have to go to kind of see that it's an infinite loop? Well, let's think about this, okay? Because for each iteration, we are multiplying the coefficient by 2, right? So even if the coefficient was 1 to begin with, I should be done in 64 iterations, right? And because we also know that E2 was a 0, so that means after 64 iterations, it would be, what, negative 64, right? So if we get to negative 65 or something like that without exiting the program, without exiting this loop, I think we're in trouble, right? So what you can now do is to get rid of this breakpoint. And in this time, I think you can only do this using the command line. You can say break, and then the line number, which is 129. And then you can say if, okay? You can specify a condition now. And you can say if E2 is less than negative 65, then we'll break. There we go. This is called a conditional breakpoint, which is going to save you, as you're debugging the program, a whole lot of tedious clicking. Click, 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 right? Okay, so now we'll continue the execution of the program until this breakpoint says, I think we are supposed to break now because E2 is now less than negative 65. So we say continue, and is it breaking? Nope, I think it's at the breakpoint now. It's at breakpoint 4, and then we say, okay, tell me what is PN, and you can see how E10, oh, excuse me, E2 is now negative 66. So the conditional breakpoint worked, okay? It gave me the ability to kind of fast forward to the point when the condition becomes true, and then goes like, okay, I'm gonna stop here because you asked me to stop when this condition is true. Is that okay? But one thing we see is, oh, look at the coefficient. It is 0. That's because I have shifted every single bit out on the left-hand side because I keep inserting zeros from the right-hand side. So every time I shift in a 0 from the right-hand side, one digit is going to get out on the left-hand side. And after 60 something, 66 shift operations, everything is out. I mean, it has been out for like 2 or 3 iterations already, but this is for sure, okay, a confirmation that I'm supposed to get out of the loop, but it's not getting out of the loop. Is that okay? So I believe that we also talked about how to fix this problem, which is to divide both sides of the comparison by 2. Okay? So that will fix the problem because we won't end up with trying to compare an unsigned 64-bit number to the largest value that a 64-bit unsigned integer can hold. So let's go ahead and stop. And this time I'll divide both sides by 2, which is pretty easy because one side just does not have the multiplication by 2, and then the other side just has a division by 2. Is that okay? So we're going to run it again. Okay? So we'll go ahead and say, now it doesn't hurt to save the file once in a while. So Control S works in online GDB as well. So you go to debug again, okay? And then go to start and hit continue and hit continue one more time. The conditional breakpoint is still there, okay? It is still conditional, I believe. I could be wrong. Let me double check. There's a way to check the breakpoints. Nope, it doesn't seem to be conditional. Nope, it is not conditional. So I'm going to put a breakpoint at the very end of the subroutine, so when it exits, I can catch it when it exits. And I can also continue to put in the conditional breakpoint. So I'm going to say break on line 129, but only if, do not type only. I said only because that's the logical thing to say, but the syntax says just if Pn points to E2 is less than negative 65, which is the same as last time. Okay, put the breakpoint over there, and then continue execution. And this time, we get to breakpoint 4, which is on line 131. So this time we got out of the loop because this is no longer in the loop. So now we ask, okay, tell me what is in Pn. And you can see how in Pn, the coefficient is this particular value. And you can plug it in to a spreadsheet and ask what is the log 2 of this value. And it's going to be 63 point something, which means, yep, this is pretty much as large as it can get. Is that okay? So right now, what do I have? I think I got the inner loop set up. Okay. In other words, I can now keep doubling the coefficient and decrementing the exponent of 2 until I can no longer double. So it's probably time for me to handle the outer loop at this point. Does that make sense? Okay. So now I go, stop the program. And by the way, this entire demonstration was not rehearsed in any way. I'm just making things up as I go, otherwise known as winging it. But sometimes winging it is not a bad thing. So once again, since I don't know exactly what I'm supposed to do, to exit the loop, I'm just going to use an infinite loop here because I can still rely on breakpoints to help me inspect whether the program is doing things correctly or not. Okay. So I think there's a way to reformat everything so it looks nice again. Beautify, that's it. So Control B, beautify, and now, nope, it doesn't like to do that.
E5 does not help.
It does not help,
You
huh?
have to go a long way. It messes up everything.
Really?
Yeah, it doesn't. It makes it uglier.
Uglify.
Uglified.
It's uglifying.
The
No,
technology
why is
pushes
it
it
not
that way.
working? Is it because of the use of tabs? Maybe. Yeah, so it's using tabs here and it's not using tabs here.
And I couldn't find a way to undo it either.
Okay, well, I mean.
So.
Okay, fine. I mean, we just have to do it the more kind of old-fashioned way, I suppose. Okay, all right. So now we need to go back to the spreadsheet and find out what are we supposed to do now. We are done with the inner loop. So between each invocation or between the inner loops, the one thing we do is we do something about the coefficient. We divide it by 10. But we don't just divide it by 10, right? If you look at the formula, we add 5 to it first before we divide it by 10. So instead of just kind of blindly copying the equation here, why are we adding 5 first before we divide it by 10? What is the purpose of that?
It was part of the rounding formula that you showed.
Exactly. So as you're writing this program, it is supposed to help you connect the concepts that you learn in class. Because otherwise, the concepts are just these embodied things that are floating around. So you want to kind of hold them together into one piece so you can see the connections. So, all right, so in the code, I'm going to do the same thing. So after we exit, and it doesn't hurt to add comments, okay? So it doesn't hurt to basically write down some comments, especially after a loop, okay? What does it mean that we are now out of this loop, okay? I do that all the time, okay? I write comments, you know, when I'm outside of a loop, right out of a loop, because it signifies something usually very important, like, oh, we are in the loop because that thing is still false, and we are now out of the loop, and this thing should be true, or the other way around, depending on which way you look at the logic. So at this point, I can say the coefficient is as large as it can go. Time for a divide by 10. Okay? Because this way, if I look at the program like 3 weeks down the line, I will still be able to understand the logic of the program. So now I need to do the division by 10. So I need to look at the coefficient. And unfortunately, this time there's no quick and easy way to do it. You really kind of have to spell out the whole thing. So it's the coefficient plus 5, the whole thing divided by 10. And after we divide it by 10, we better change E10, right? So we need to say E10 is going to change, and we need to increment E10 because that will compensate to make sure that we are still referring to the same value. All right, so I keep this as an infinite loop because I can now set a breakpoint right here. Okay, this one I don't really need anymore. So I'm gonna go run the program again because I just want to check whether per iterations it's still doing the right thing or not. So I go to debug, click, click, click. Okay, start, continue, continue. There we go. Okay, so now we need to get rid of this one because otherwise it stops every iteration, which is not what I really need at this point. So I just say continue, you get to this point, and this is before the actual increment. So I'm gonna step over, okay? And now I can um, take a look at what PN is pointing to. Oh, it got all the way out, didn't it? No, it got out to here. So PN should still be visible. Oh, print. Okay, forgot about print. There we go. Print PN. So it reports back a coefficient that is like this. And then E10 is now 1 more than what it used to be. And then E2 is negative 57. How do I know whether this is right or not? It's just a bunch of digits, right? Yep.
Check the spreadsheet.
Well, the spreadsheet is not going to help, unfortunately, because the spreadsheet is based on a 32-bit unsigned integer. So it's not going to help directly, but you can set up like a new sheet, just for clean calculation purposes. So what you can do now is to say, I want to calculate this, right? So I'm going to go back to online GDB and just copy this whole thing. Okay, Control C. Oh, great. Control C just stops and breaks the entire program. So I can do a right click and copy. That's okay, because I just need to do this one last step before I kind of move forward. So I just paste this value over here. This is my coefficient. I just use a cell for it, okay? So this way I don't have to worry too much about having to copy and paste as I'm in the formula. E10 is negative 46, okay? Once again, right click and then copy. Don't do the Control C. And I have to do this quickly too because otherwise it's going to time out and then the debug session is going to be gone completely. So just one more. There we go. Right click, copy. Okay, now we're good. So go back to the spreadsheet and paste it here. Okay, so let me just add one more column, just so that you know which one is which one. So this is our coefficient. This is our E10, and this is our E2. All right, so what is V? V is the coefficient times 10 to the power of this value times 2 to the power of this particular value. And I should get back to 1.23 times 10 to the power of negative 45. You go like, nope, Tech, you didn't do it right. Well, that's because, by default, it is not displayed as scientific notation, and the value of this thing is so small that most people would just consider it close enough to 0. Well, not in our case because we need to kind of work with this value. So we have to go to number and turn it into scientific notation, and voila. So that means the value is still preserved. So the only thing left for me to do now is to say, well, I don't think that's supposed to be an infinite loop. It's supposed to get out at some point. So, but that's the easy part because we keep incrementing E10 from negative 47 to negative 46, and eventually it's going to get to 0, and that's when we need to get out. So just to complete the program, more or less, because there's one little thing that you kind of, most people would miss, but I'm going to address this part first, okay? So as long as E10 is less than 0, That's what I'm going to do. Not less than or equal to, just less than. Because the moment E10 is 0, I'm done. Is that okay? All right. So now I run the code again, and this time I'm not going to put this breakpoint here because I'm pretty sure this is working. So now I can put a breakpoint all the way out to here after the outer loop is done. Okay. So I go to debug again, and then click start, and I'm gonna get rid of server. The breakpoints shifted because I inserted additional lines, so things just got moved around a little bit. Okay, and this breakpoint is not really needed anymore. And now we're at the end, which means we're out of the loop. So now we say print what is pn again. And once again, we look at these values and go like, we have no idea whether this is right or not. So once again, you'll do a copy and go back to the spreadsheet and change the cells. This is why I like spreadsheets, because you can keep the formula and populate the values just differently. So it eventually it saves you time because E10 is basically 0 at this point. So I just overtype it with 0, and then we just have to figure out what is um, negative 209. Okay, thank you. So copy again, go back to the spreadsheet, and then we do a paste. Aha! Okay, we are still representing exactly the same value as before. This is great. I think I'm done. No, wait. You have to read the assignment carefully because the assignment says the coefficient has to be, it has to use all 64 bits. So now we have to say, how do we know whether the coefficient is using all 64 bits or not? In a spreadsheet, it's pretty easy to do. In GDB, it's a little bit harder. Okay, so since I'm in the spreadsheet already, I need to look at this particular value and go like, is it going to use up all 64 bits? The quickest way to do it is to use log. So now you basically try to say, okay, let's take a look at the log of this divided by the log of 2. So this way, we're essentially using log 2. And you look at this and go like, it's supposed to be 63 point something, or exactly 64, but it's not. Why? Yep.
It's because you can continue to double it, like a couple times more, right?
Well, right. But the reason why it is not why it's not 63 point something is because the last operation in the loop was what? Division by 10. So even though it was using all 64 bits, after you do a division by 10, it's not anymore. So what you need to do is to repeat that loop to keep doubling it until it is once again the largest coefficient that fits in 64 bits. So that would be just the last bit thing. I'm not going to take out a lot of points because somebody is missing this part. Okay, because if you get the rest done, that means you're really kind of understanding the whole thing. But I also cannot not take any points off because it is a part of the specification of the program. But it's just not going to be a lot of points. Okay, so let me just finish this entire thing, just so that you can have a reference of what it looks like. So we'll go ahead and do another loop here, and all it has to say is as long as the coefficient is less than u int 64 underscore max divided by 2, yeah, just do the doubling and decrement e2 at the same time. That's it. That's just the last bit of thing that we need to do. All right, so let's double check to see if this program is still working correctly or not, because I do want to make sure before I kind of conclude this part of the lecture. Okay, so we start execution and we just continue. Oh, okay, I just missed it. Do it one more time. There we go. So now we are at this breakpoint, and I'm going to print pn, and this time we have this value to copy to here. And I think, yep, 213, negative 213 is the new E2. So we have negative 213, and we got the value back. But this time, you can see the log 2 of the coefficient is indeed 63 point something. So I know I have met that extra requirement. All right. So any questions, comments, feedback about this particular session? How to use GDB to interactively develop a program. Okay. If you guys don't have a question, I have a question. Um, were you guys taught how to do this, like what I just demonstrated, in your other classes? Okay.
Not to this extent.
Okay.
We
Since
dabble.
since I'm not recording my facial expression, I'm gonna have to say I'm face palming right now. Okay. Because this is important. I think the features of C and C++, the concepts are all important, but the process of writing a program and how you debug a program is equally important, if not more. And that's basically what the lab is supposed to be for. For CISP 360, 400, and 430, those all involve heavy duty programming, and that's what the lab is supposed to be for. Is for the instructor to help you utilize a debugger or tool of some kind to help you figure out why your program may not be working the way it's supposed to. Um, okay. So, but is this helpful? I mean, or do you guys think, oh, this is just a waste of time?
Absolutely. I think debugging, I mean, the way you broke that program down
Mm-hmm.
was much, it just didn't have a lot of room for mistakes, because you can actually
It
just kind of,
it does. I mean, I make mistakes all the time. Okay, forgetting about the condition, flipping, using less than or equal to instead of less than, that sort of stuff. The key is how quickly can I find the bugs? That is the key. And using a debugger is going to shorten that time by a whole lot because it just gives you the ability to say, okay, pause here. I want to see what is the value of that variable at this point. So if the value of the variable doesn't make sense anymore, you have just walked past the bug. You have no idea how far you have walked past the bug, but you know that the bug happened already. Something bad has already happened. So now you can set up another breakpoint at an earlier point of the program. Or if you use conditional breakpoints, now you can say, I wanted this thing to pause before that value gets all the way down here because something went wrong earlier than that. So, um, so knowing how to use the tool is really, really important. I think it's really important. And GDB is really useful because GDB is the actual debugger behind CodeBlocks. It is behind online GDB. It is also behind Replit, but I couldn't get Replit to work. I really tried to get Replit to work, but I could not. Okay, there's something weird going on, at least when I tried it. I'm not sure about VS Code. I suspect VS Code also uses GDB. If you convince VS Code to use GCC or G++ as the compiler, I think it automatically uses GDB as a backend, which means you probably have access to the command line of GDB, which also means you can now set up conditional breakpoints and watch expressions and all the kind of really useful but a little more advanced features of a debugger. All right. So are we good? Maybe? All right. So today you still have to work on the positive exponent component. And I have no problem if you guys want to use this program to quote unquote inspire your code for the new program. So I don't have a problem with that at all. So let me save that program first and then distribute it as an announcement in Canvas. So let me see how I can do that. So first up, and then save. Okay. Okay, now how do I get it back? I know I can publish it.
There's a download button right there.
Hmm?
There's a download button right there.
Which button?
Next to Beautify.
Oh, download. Oh, okay. Thank you. Yeah, we can download as main.c, sure. And then go back to the class, go to announcements, and and attach that. I know that feeling. Yep, this is the. Yeah, it's not so much the program that is important, it is the process that is more important. All right, there you go. So now you guys can, if you want to, you can use this as a starting point. I'm not really sure how useful it is, okay? Because the program, the positive exponent program, is not exactly the reverse of this one, okay? But it does have things that look like this one, except the two becomes the 10 and the 10 becomes the two ish, okay? But it's still not exactly the same, okay? So you still got to work on that one a little bit. But the process, is what I really want to show today is how do I do it? What is the process of writing a program? All right. So with that said and done, I do have a new module that I wrote, that you guys knew already because I was using a spreadsheet already, but I never really wrote down the process itself, how to track changes of a circuit. So I'm going to copy and paste it into. Oh, I forgot to take row. Okay, my watch buzzed already, but I forgot. I was just in the conversation at the time. So that's going to be 20221012. I'm going to take row. And okay, so I'm changing the format so that it's just the access code that you need to type in. The access code is asterisk equal to, which was the the bug that I had earlier, or how I fixed the bug earlier. So I'm going to give you guys all the way until 11:50 to enter that. Not to enter that, but to get into it, to basically say, yes, I am present in class. There we go. So now you have quite a bit of time to do this as I do something else on Canvas because I got this other thing that I need to do. All right. So I need to add a new external URL. And here it is. And this one has to do with tracking.
Oh, I
Hmm?
guess. I guess the word was overflow and the access code was star keep this time.
Oh, okay. Obviously, I did not test that, did I? Okay, so I'm going to do that. Just give me a moment here. Okay. What did it say?
It's overflow, but the access code. I think you set the access code so that star equal.
And then the word is supposed to be overflow.
Oh, okay. Oh, I forgot to save the question. It's okay. I just have to kind of go in and manually check that you guys are in. So if I see a zero, I turn it into a one. But if I see a dash, which means somebody did not even bother to participate, I'll change that to a zero. So don't worry, no worries. I'll fix that. Yeah, that's one thing about Canvas is I can change the question, but if I don't say save the question and save the quiz, it doesn't automatically save the question also, which is like another face palm moment. Yep. All right, so getting back to here, okay, tracking change propagation. That is, I just wrote this because I want to summarize in writing what we did to keep track of um, the change propagation of the SR latch. Okay, did I demonstrate how the SR latch is going to oscillate? Because when we switch both inputs from 00 to 11, I did. Okay. Okay, excellent. So what we'll do today is to use this technique on a different circuit. We got about half an hour or so. I think we got enough time. All right, so we're gonna switch to a different circuit. Okay, we'll switch to the next one, which is a level sensitive D flip flop. This is what we call, well, okay, without the name, level sensitive, it is implied that it is level sensitive. So the first thing we need to do is to turn this into a format that we can track using a spreadsheet, okay? And that's what we're gonna do. So let me go back to my drive, which is here, and there is one document already for the Tuesday, Thursday class. Don't use that one because I want you guys to use the Monday, Wednesday class as I go through the trace, okay? Because otherwise you just see something that's already completely done and it's not going to be helpful in the process. But I cannot find the one that we worked on the other day. Did I share that with you guys? Did I use a spreadsheet the
You
other
used a
day?
spreadsheet, but I'm not sure if you shared it.
Okay, so that means it is probably somewhere else. All
That's
right.
not the same one that's the Tuesday, Thursday SR.
Yeah, this one is Tuesday, Thursday only.
Maybe it's Tuesday, Thursday. I don't know.
No, it's okay. I can still use,
No, definitely,
no,
definitely not.
definitely not. Okay, so that means, okay, give me a second here. I can go to recent. All right, so what did I do? There you go. So this is the one that we talked about. The question is, where did I put it? So let me see. Okay, if I move, it's in its own folder under circuits. There we go. Okay, so now that I can find it, let's not move it and just go back to here. Um, oh, now I have to go back to my drive. Okay, let me show you where to find it. All right, so this is where you can land if you follow the link. So you have to go to circuits and then SR latch, and this is the one that we looked at. So let me um, double click it. There we go. Does that look familiar?
Yes.
Okay, excellent. So what we'll do today is we're going to add a new sheet because now we have a new circuit to build. So the new circuit is based on a level sensitive D flip-flop, which is like this. So this time I'm just going to copy and paste the text description and put it into the spreadsheet. Um, yeah, I encountered this problem with the other class too. So even though I could do this, for some reason, the horizontal scroll bar does not appear on the left-hand side. So it's going to be an issue. But I can fix this issue gradually, step by step. Okay, so let me put this back here, and I'll just kind of stash it all the way here first. Okay. So according to the text description, we need a few things in the tray, right? We're trying to collect the parts that we need. The first one is AND, which is a NOT gate. So the NOT gate has one input pin or input port, and it also has one output port. The next two are N1 and N2. They're both NAND gates with two inputs. So we have N1, it has one input, two inputs, and a single output. And as I do this, I'm going to use this feature to make things more compact. So now we have N2. N2 is kind of the same deal. It has got two inputs and one output. And highlight all of this stuff here. All right, so I am running out of space, and I will still have one SR latch and 4 pins to deal with. So I need 8 more columns. So the way to insert additional columns is to mark as many columns as you need in addition, and then you right click, and then you say insert 9 columns to the right of these columns. So that's a pretty nifty feature to insert a bunch of columns at the same time. So after N2, we got SR latch. The SR latch has SR as inputs, Q and NQ as outputs. And then we have the pins. So we have the input pin D and EN. The output pins are Q and NQ. There we go. And as input pins, the only port they have is just the pin itself. Okay, there we go. All right, so each column is now representing a port. A port is basically a connection point that you see in Logisim. So every time in Logisim, you hover your mouse pointer over something and it highlights and say, hey, this is a point where you can connect a wire to. That is a port. Is that okay? So some devices only has one single port, such as the pins. Some have two ports, like one for input and one for output for the NOT gate. Some have three in this case, so the NAND gate N1 and the NAND gate N2, they both have three ports, two for input and one for output. Are we doing okay so far in terms of the terminology, what a port is? So now we read the text description in order to make the nodes. So a node is basically a logical thing that connects a bunch of ports together. So according to the text description, D.pin N1.in bracket 0 and then N.in, they all belong to the same node, which means electrically they are connected by a physical wire. Is that okay? So a node is basically electrically, how do we connect multiple different ports, together. So what we're going to do now is to use color coding. So we have D.pin as 1. We have N1.in0, which is this guy here. And then we have N.in, which is this guy over here. And then we can use a background color to kind of indicate that they all belong together. So I'm going to use a gray here, okay, because from the previous class, I know that I'm going to run out of colors. All right, so the next one is en.pin, which is this one, n1.in1, which is this guy, and then we have n2.in0, which is this one. So we'll pick a different color, and I'm going to pick red in this case, or very pale red. The next one is n.out, which is here, and n2.in bracket 1, which is here. So we'll highlight that one, and we'll use orange. And then the next one is n1.out. So n1.out is right here, connects to sr.s, which is here. So we'll go ahead and use a yellow color this time. And then we have n2.out connecting to sr.r, which is here. And whoops, there we go. And then we'll pick the next color, which is green. And then we just have sr.q connecting to q.pin. And there we go. Light blue, light cyan. And then this one connects to this one. That's the last one that we have. And we can use purple. There we go. All right. So if I pre-apologize to people who are colorblind because I'm not colorblind. So they all appear, these colors, they all appear to be distinct to me. But for colorblind people, they may not. Um, from what I know about colorblind is it's the blue and the green that is the issue. They cannot differentiate, like shades of green, blue. Um, is anyone colorblind? Nope. Okay. All right, so we're good here in terms of color coding. Okay, so what do we do now is we say, let's assume we know nothing about this entire circuit first, right? So this is the initial condition. Initial condition is everything is unknown. Whew, there we go. And then what we want to do is to say input change. So what do we want to do about the input at this point? So I'm going to D and say I'm putting a 0 here, and I'm also putting a 0 into EN here. And then the question is, do you want me to separate the change propagation because of the node connectivity from the changes because of the device itself? Well, first of all, is that question understood? The first one refers to if the red pin connects to these two red pins. So when EN dot pin is getting a 0, these two should be getting zeros as well. That's what I mean by connectivity by node. And it has nothing to do with the behavior of the NAND gates or the NOT gates or anything like that. It's just because they're electrically connected. So if you want me to separate those two onto two different rows, I think it's easier to understand. So maybe we should do, yeah.
EN's an input pin?
Yeah, so the input pins, so according to the description here, D and EN are my input pins. So the input pins would be this column and also this column.
I guess it's kind of hard to tell without a circuit in front of
that was kind of my experiment, is to see whether you guys are okay without a visual of the connectivity. So do you know? Because I was just going with the color. I was going like, oh, this is red, and so are these two. So all the reds should have the same value. But you guys don't like that.
That makes sense, but it's like it kind of takes away from everything without a picture in front of it, because now you gotta kind of like keep a mental map, and that's kind of hard, at least for me.
Okay, so I can make a logic sim. It might take a little bit longer, but that's okay. So it might take just a little longer if I did that. All right, just give me a second to fire that up. There we go. Nope, doesn't like that. All right, so now we have Logisim, and we're gonna have to redo all of that. So we got two inputs. Following the color actually is easier for me.
I'm more visual as well. I like to see how it's connected,
Okay.
kind of stuff. So
At least when learning this stuff, not this is like the first semester I ever. Well, besides like working with Arduino's and Design Hub, this is the first time I really like looked at circuits.
Yep. Okay, that's fine. So let me pull the right components first. We have one NOT gate, and then we have two NAND gates. But the NAND gates both have two inputs, and we'll make it narrow, like so. All right, and we have two of those. This is N, and this is N1, and this is N2. And then we also need an SR latch, so I need to make the SR latch first. So this is our SR latch. All right, so the SR latch is going to need two NAND gates. So I'm just going to borrow these two and paste it here. Okay, one more time. Control C and Control D over here. All right, so we need two input pins. One here and one here. And then we have two output pins. The reason why I think the without the graphics is better has to do with I want to describe the process. So the process itself does not depend on how we. Oh, okay, that's a wrong connection. I'll fix that. I will fix that. Okay. There we go. So now we have a SR latch. So we can use the SR latch over here. There we go. All right, the SR latch is simply called SR, like that. All right, so now we need to hook up everything. And that would be the part that is a little bit, this is actually harder for me to hook up the components. So we got D, N1, first input of N1, and the negation gate hooked up together. All right. So we got D, we got the NOT gate, and I think it was N1. Let me double check. Because I cannot track these things that well. Okay, I think that's right. So we'll hook that up, and it will hook that up. Okay, so that's one node. The next one is EN goes to the second input of N1 and the first input of N2. All right, so we'll get that going. Okay, first input of N1 and second input of first input of N2, second input of N1. There we go. And then N dot out, which is the output of the NOT gate, goes to N2 dot in1. So this goes to this over here. And then N1 dot out goes to SR dot S. So that would be the easy part. So this goes here, and then that goes here. And then these two are just straight up connections. Q goes to Q, NQ goes to NQ. There we go. All right. So that's the appearance of the circuit. I can copy and paste this. I can take a screenshot of this and then paste it into the spreadsheet. So that way it's easy for you guys to actually see the circuitry. Oh, that's not what I intended to do. One more time. I want to put it in the clipboard. There we go. Okay, so now switch back to the spreadsheet again and do a paste. There we go. So that helping?
Thank you.
All right. All right, so you guys can choose which way you want to use to track the changes. I'm going to go by the color code. You guys can go by the wiring. All right, so by the color code, okay, um, whenever D is changed, all the gray ones are supposed to change at the same time. So this one also needs to be a 0, and this one also needs to be a 0. This is a red one, so when it updates, so all the red ones need to update at the same time. So we need to update this one as well as this one. Are we good so far? Okay. Now all of these are new because they used to be unknown and now it's a 0. So I'm going to have to boldface every single one of these just so that I know what has changed. So these all have changed, and then everyone else is just what it used to be, question mark, question mark, question mark, bunch of question marks, like that, and then 2 more question marks. There we go. All right. So what I have just done is to um, change the state of ports that are connected because of how the nodes are set up. Is that okay? So this part has nothing to do with the behavior of a NAND gate or a NOT gate or an SR latch. This part only has to do with how things are wired. Is that okay? So now, after a certain propagational delay, then we have to ask, did I just change at least one of the input pins of something in the previous step? That's what I need to ask.
Probably, because they were question marks before, right?
Yep. Anything that is bold-faced, that is an input, tells you that, okay, we did change the input of at least one input of a component, right? So the question now is, what components have at least one of its inputs changed?
Yeah. Well, at least them. Yeah, at least the end.
Okay, so if the input of n is changed, we need to figure out the output, right? How about n1? I think so. I mean, both of the inputs of n1 got changed, so we need to figure out the output of n1. With n2, only one input got changed, but I would still want to be able to kind of look at the output of n2. The SR latch is fine because both input pins, which is S and R, they are not touched, so they're fine. The pins are not a big deal, okay, so I'm not too concerned about the pins. All right, so let's focus on N, okay, which is a NOT gate. Yep.
Wait, why is SR input questionable when N1 could possibly change and N2 could possibly, or?
Because at this point of time,
Mhm.
SR has not experienced any changes to its input pins.
Okay.
So that means nothing is going to change with the SR latch
Right.
because none of its input has experienced any changes yet.
It's not until we actually go through a proper propagation of delay
Right.
that we have to check.
Yep. So right now we what we know for sure is for N the input has changed. So the focus is what is the output of N after a propagational delay, and now we are ready to look at the change of the output. Can we determine the output of N? N is a NOT gate.
Yes.
And what would that be? It's going to be true. Okay, very good. And because it's new, we're going to both face it because it's a change. What about the output of N1? And N1 is a NAND gate.
It changed.
Okay, it got changed. And how is it changed?
It's true now.
It is true now. Very good. Okay, what about, okay, let's both face it. What about N2?
It also changed.
2.
True.
Yep, very good. And that's it. Okay, so these are the changes. But now we have to follow the colors. Okay, or if you prefer, you can follow the circuit. Because if the output of N got changed, then all the orange ones also need to change. Or if you look at the circuit, if the output of N is changed, then whatever it connects to also need to change. So that means N2 dot in bracket 1 also need to be changed. Okay, so we'll go to this one and say, that got changed. What else? This is yellow, okay, in terms of the color scheme. This is yellow, so all the other yellow ones should also be changed. And this time we are indeed changing one of the input pins of the SR latch because this one now is going to be a 1. Or if you look at the diagram, we are looking at the output of N1, and that connects to the S part or the port S of the SR latch, right? And then we got one more. We got the orange.
The R input? Oh, no.
We got the green because we just changed we have just determined the output of N2 to be a 1. So all the green ones also need to change. Or if you look at the diagram, whatever N2 output connects to, which is R of the SR latch, that also needs to change, which is also a 1. Whoops, just pressed the wrong key. There we go. So are we good so far in terms of, we first do the propagational delay. Using the behavior of a gate, we determine based on the input change, what is going to be the output of the device. That's the first step. The second step is to say, well, now that we know the output of stuff has changed, how is that going to impact the other things connected to these output ports? And that would result in following the colors in the spreadsheet, or if you prefer the more graphical way, you're following the actual wiring of the circuit and say, well, if this changed, then those things would also change at the same time. Is that okay? So it's a two-step process for each row of the trace. Okay? All right. So everything else is going to be the same. Okay? I'm just going to copy the rest. Okay? Things that are the same as before. Question mark, question mark. Um, and these are maintained. So even though they are zeros, they did not change from before, so they are not bow-faced anymore. Is that okay? So now what do we do? What is the next step? The next step is to once again look at all the devices and note any one that has at least one of its input pins changed on row 5. Let me say that one more time. on row 5, we need to identify which device has at least one of its inputs changed as boldface, and then we have to basically ask, uh, what do we know about the output at this point of those devices? All right, so we'll go through the devices one by one. First one is N. Is the input of N changed in any way on rows 5? Okay, nothing there, so we don't have to worry. What about N1? Is one of the inputs of N1 changed on row 5? Nope. Okay, so we don't have to worry. What about N2? Yeah, okay, so we're gonna have to kind of leave a little placeholder here to remind ourselves to kind of do that calculation. What about SR?
Yes.
Both.
Yes.
Yep, you're correct. Both inputs got changed. So now we have to look at both outputs and say, well, we kind of need to say something about it, maybe. All right, and then the pins are not really too big of a concern, so these do not have input-output. They're just points on the circuit where you can exert changes or you can detect changes. So they don't actually react to anything at all. Okay, so we look at this square or this cell, look at this underscore, and we ask, well, now that we know the first input of N2 is a 0 and the second input of N2 is a 1, what is the output of N1? N1, by the way, is excuse me, I kept saying N1 is N2. So N2 is a NAND gate.
So it'll be true.
It will still be true, but because it is not a change from what it used to be, it is no longer bold-faced. Is that okay? Because we only bold-face to note a change from what it used to be. All right, what about this one?
That's actually false now, right?
It would still be unknown because if
Q.
both inputs of an SR latch are ones, it means maintain your current state.
Oh, the SR latch that we were talking about last time. So it means maintain.
Yep, it's just maintained, whatever it was. Yep. So that's it. All right. So that means we did not, there are no changes. Because you can see, anything that has at least one input pin change, their outputs stay exactly the same as before, and we're done. So this is how we arrive to what we call a steady state, which means, yep, everything is cool now. Okay, there are no more things being changed and being propagated. Question?
There's 2 question marks in a solid state.
Hmm. Yeah, and that is exactly that is exactly reflected in Logisim. Do you see how in Logisim we got 2 red wires and 2 E's? That's because when the SR latch came into existence, it says, I have no idea what the outputs of the NAND gates are, right? And then what we did was we hook up 1 and 1 to its inputs, which is basically just saying, whatever it was, keep it. But I have no idea what it was before. And hence the red lines and the E, because it is quote unquote error. It's not really an error. It simply means I do not know what it is supposed to be. And that is consistent in the spreadsheet, because in the spreadsheet, they are simply represented as question marks. So when the output of a device is unknown, in Logisim, it is reflected as an E with a red line, but in the spreadsheet, it's simply just a question mark.
So, I'm like a big picture guy. So, like, what is this circuit helpful for?
Okay, so let me get back to that, because I want to uh, finish this first, and then we'll go back to the circuit. All right, so in the circuit, um, D is the data that you want the circuit to remember. En is enable. So when En is a 0, it means ignore D. I'm just babbling. Okay, so you can see how when En is a 0, I can change D all day long. Okay, wait, change to the poking tool. I can change D all day long, and you can see the SR latch says, I'm not hearing anything, right? So that's what it is supposed to be doing. En is enable, and then D is representing the data, which is one single bit in this case that you want the device to quote unquote remember. To remember is basically saying, I want whatever D is to be reflected in Q. So Q and D should be the same when I say, yes, go ahead and remember whatever is on the D port. Is that okay? So when EN is a 0, I'm simply telling this entire device and go like, just ignore whatever is on the D port. I'm just babbling. Okay? Just don't pay attention. So if you want the device to remember a 0, you first have to set a 0 over here. Well, I shouldn't say first, but you set a 0 here first, and then you can enable the device, which means you're telling the device to go like, okay, now I want the Q output of the device to reflect exactly what D has. So the moment I click a 1 here, you can see how the SR latch now knows, oh, okay, I want to make Q to mirror whatever D is. And then NQ is just the negation of Q, so it's not a mystery in this case. It's just a negation, the negated version of Q. Is that okay? Now, this device is called level sensitive because as long as EN is a 1, it will keep mirroring whatever D has in Q. Now, I just said something, right? So how do I test it?
Truth table.
In this case, you don't need a truth table because the circuit is already done. So yeah, exactly. We just change D, and you can see how Q is changed immediately. Well, not exactly immediately, but it did change. And then if I flip it back to 0, you can see how it flips back to 0. So this is one exercise I'm going to give you. It is not going to be graded, okay, because you already have the positive exponent assignment that is going to be graded. This is not graded. And that has to do with using the spreadsheet approach, do exactly what I just did in LogicSim. Okay, so let me switch back to the spreadsheet. So that means, at one point in time, I want to switch so that, D remains a 0 and E is going to change to a 1. And then after this, I want EN to continue to be a 1, but I change D from a 0 to a 1, and then change it back. Okay? So this will give you an opportunity to get used to how to use a spreadsheet or a table to analyze the effect of a circuit when I present changes to the input pins. So now you understand, oh, okay, if this pin is changed, it's going to change that input of that device over there. After a propagational delay, the output of that device is also may change. And that change can affect the input of those other things. And then you just track all of these changes as all the changes start off as changes to the input pins, and then eventually they may affect the output pins. But the idea is they all should end in a steady state. So you should not get into an oscillation situation where when you change both the S and the R pins of the SR latch from 0, 0 to 1, 1, then we get into an oscillation. None of this should get you into oscillation. So they should like only be a few steps, and then it gets into a steady state, and you copy that steady state as the first state of the next one, and then you keep doing this. And I think that would be a good exercise. I can go over the answer to this particular exercise. It's already in the spreadsheet. So all you have to do is to copy the spreadsheet to your own Google Drive. Then you can work with it any way you want. Is that okay? All right, so I think the lecture portion is over. Um, this is the lab portion. So at this point, this is going to be the last lab session, where it's kind of like, well, if you guys want to work on your program, independently, you can do so. But if you want me to take a look at your program, you can do it here, and I can come over and take a look, and also make some suggestions of how to use GDB to help find out why something is not working. All right, so I'm gonna stop the recorder in OBS, and you guys can stay here, or you guys can work on your program somewhere else. I think some people may have the program done already. Okay, stop.